Hello everyone, this is Hating Tian. This video we are learning partial fractions. First, let's review adding rational expressions. If I have two rational expressions, how to add them together? We need to find the LCD, lowest common denominator, and then convert them to have the LCD, combine the tops. So first, let's see, the LCD is x plus 1 times x minus 3. So the first rational expression can be written as 3 over x plus 1. The top and bottom multiply by x minus 3. And the second rational expression, 1 over x minus 3. Top and bottom multiply by x plus 1. Now we have the same denominator. Add the tops. We have x plus 1 times x minus 3. On the top, we have 3 times x minus 3 plus x plus 1. We can also move it here. We can distribute the 3 in the parentheses. We say clear the parentheses. We have 3x minus 9 plus x minus 1, all divided by x plus 1 times x minus 3. So the top is 4x plus, this is, there's something wrong. Here is addition. So 4x minus 8. Okay, all divided by the LCD. Okay, you see, we combine two rational expressions into one. Now, in this class, we're going the backward. So if I have one rational expression, can you express it as something on the top? So for example, this one is 3 and divided by one of my factor of the denominator, and then plus another number or another constant divided by my second factor of the denominator. Okay, now we need to know how to find the 3 and the 1. Okay, let's see. Type 1, non-repeated linear factors. So if I have a denominator, the bottom is x minus a times x minus b times x minus c, and on the top is a function. Then I can decompose it. I can rewrite it into this. So the first factor, the bottom, the first factor on the top, we have a constant number a. A divided by first factor x minus a, and another constant number b divided by second factor x minus b, and the c constant number divided by x minus c. Okay, so how to find the ABC's value? Then plug it into the top so I can find the decomposed form of my rational expression. Okay, let's see the first example. Example 1. Okay, the bottom is x squared minus 2x minus 3. That means I can factor it. For example, I factor it. And then it can be written, this is my first factor. Let's say factor 1, x, I don't know what is that. I should use AM or AC method. For example, this factor and this factor. So this expression, rational expression, can be written as a over the first factor plus b over my second factor. Okay, if I can know what is the a and b's value, so we're done. Okay, let's see what is the process. Let me read this. The first step is factor the bottom, factor the denominator. Then second, set up the equation. First, second, multiply the LCD both sides. Number 4, let the x be convenient value. Then solve for the constant number a, b, and c. Okay, let's follow the steps. Let's see. Factor the denominator. On the top, it is 4x minus 8, and the denominator can be factored by using AM method. Okay, it is x plus 1 times x minus 3. Okay, so we can set up the equation. That is 4x minus 8 divided by x plus 1 times x minus 3 is equal to a constant number a all divided by the first factor plus b times second factor. So if I can know the a and b's value, we're done. Okay, so next step, both sides multiply by LCD. The LCD. So if you see these two rational expressions, what is the LCD? That is the multiplication between them. So it is x plus 1 times x minus 3. So let's use LCD. Multiply by LCD both sides. That means both sides multiplied by LCD. Cancelled out my denominator. This one cancelled. So we only have the 4x minus 8 is equal to, equals a divided by x minus 1. So if you have 8 over x plus 1 times the LCD, x plus 1 times x minus 3. So these are cancelled. We're having a times x minus 3. Then plus b, do the cancellation, is b times x plus 1. Now we need to choose some convenient value to solve for the a and the b. So first we will set the first denominator or the first factor. Okay, we will set this part. So we will set this part is equal to 0. And then later we will set this part is equal to 0. So first factor, x plus 1 is equal to 0. I can tell x is equal to -1. Plug it into this equation. So 4 times -1 minus 8 is equal to a times x minus 3 plus, can I say I don't have to have the plus? Yes, because my parentheses is equal to 0. X plus 1 is equal to 0. So I don't have to have this part. So we have this equation. Oh, the x has must be replaced. So here, this x is -1. So it's -1. So we have -4 minus 8 is -12 is equal to a times, times -4 divided by -4. So a is equal to 3. We solved our a. We need to find the b. So second, we can set our second denominator. X minus 3 is equal to 0. X minus 3 is equal to 0. X is equal to 3. Bring it into the equation. We have 4 times positive 3 plus 8. Oh, no plus, minus. Minus 8 is equal to a times x minus 3. But x minus 3 is 0. I don't have to have my first part. I have b times 3 plus 1. So we have 12 minus 4 is, 12 minus 8 is 4. 4 is equal to b times 4. b is equal to 1. We got a's value, b's value. So our expression 4x minus 8 divided by x squared minus 2x minus 3 can be written as, we say a over x plus 1 plus b over x minus 3. We found our a and b's value. We just replace the a and b with 3 and 1. So we're done. Okay. Example 2. First step, we should factor the denominator. Okay, let's see. The denominator, we have x cubed minus 2x squared minus 8x. 3 terms, they all have the factor x. Let's factor out the x. The leftover is x squared minus 2x minus 8. We can continue to factor the denominator, the parentheses. We can use the AC method. We can use the AM method. So let's say we use AM method. We got x minus 4 times x plus 2. Oh, sorry. I cannot change the top. Be careful. That is 3 on the top. Then we can list the equation, or we should say set up the equation. 3 divided by x times x minus 4 times x plus 2 is equal to a over first factor x plus b divided by x minus 4 second factor plus c over x plus 2. If you don't like the parentheses, it's okay. You don't have to have the parentheses at the bottom. Okay, let's see. Next step is find the LCD. Both sides multiply by LCD. The LCD is x times x minus 4 times x plus 2. So both sides multiply by LCD. So we have 3 is equal to a times x minus 4 times x plus 2 plus b times x plus 2 plus c times x times x plus 4, sorry, minus 4. Okay, let's see what is the convenience value. What is our first denominator? X, or first factor of the LCD is x. We can say let the x is equal to 0. And then we have 3 is equal to a times 0 minus 4, negative 4. And then 0 plus 2, 2. And the rest of them, they all have the x and the x. That means they are all 0. Then we can solve for the a. A is equal to, 3 is equal to negative 8a. So a is equal to 3, negative 3 over 8. Second, I can let the second factor, or second denominator, this one, x minus 4 is equal to 0. So x is equal to positive 4. You must know, how did you find the x is equal to 4? Is x minus 4 is equal to 0. Find the x is equal to 4. So 3 is equal to, which part is 0? So here and here. So we only have the middle term, which is b times 4 plus 2 is equal to 3. And let's do the computation. 3 is equal to b times 24. So b is equal to 3 over 8. 3 over 24. So it is 1 over 8. What is the last missing information? C. So let's find another convenient value. X is equal to negative 2. Because finding this, we let the x plus 2 is equal to 0. Then we have 3 is equal to, now which two parts are 0? So here and here. We only have the 3 is equal to c times negative 2 times negative 2 minus 4. So 3 is equal to negative 12, positive 12 times c. So c divided by 12 both sides, 1 over 4. So we plug in the ABC's value in the equation. We're having, so let's list the equation. 3 over x cubed minus 2x squared minus 8x is equal to a over x plus b over x minus 4 plus c over x plus 2. Let's replace the ABC by its value. So a is equal to negative 3 over 8. and b is equal to 1 over 8. C is equal to 1/4. We can bring the denominator to the bottom. Okay, so it is negative 3 over 8x plus 1 over 8 times x minus 4 plus 1 over 4 times x plus 2. So we decomposed our expression, rational expression. All right, let's move on to C, repeated linear factors. So the previous examples, you can tell that the bottom here, we don't have repeated factors. We have x times x minus 4 times x plus 2. Now we are going to have some repeated denominator of the factor. So for example, if I have a denominator q is equal to, so for example, I say the denominator is equal to x minus a cubed. So we know the denominator can be written as x minus a times x minus a times x minus a. And they are repeated denominators. I cannot say that we have x minus a, top is a, and b, x minus a, because they are the same. So what should I do? I should do this. First, we see the base, which is base of the 3. So base of the 3, which is one factor of the denominator, x minus a. So on the top, we say it is a, and then plus b over, so raise it to the second power, and then plus c, and raise it to the third power, until my power meets the power 3. And for example, if I have some other expressions, for example, we have, maybe we have px is a function, all divided by x cubed. So separate it into the fractional partial fractions. So they are a over x plus b over x squared plus c over x cubed. So how about this p of x on the top and divided by x plus 6 squared? So it is x plus 6 on the top is a, b over x plus 6 squared. Until I meet the squared, until I meet the power, it is squared. All right, let's see the procedures. Oh, here. We have an example. Before we expressed this one into the decompose the denominator. So find the equation, and then we talk about the procedures. So first we see the denominator is x squared times x plus 1 cubed times x minus 3. So the first fraction is a divided by x. A divided by x. And then plus b divided by x squared. Okay, I meet my power 2. Let's continue to find my second factor, which is x plus 1 cubed. So we have c over x plus 1. Then plus d divided by x plus 1 squared. And then plus e divided by x plus 1 cubed. Yes, I meet the power 3. Then plus f divided by x minus 3. So the last factor doesn't have a power. So we say x minus 3. Okay, we are not solving the a, b, c, d, e, f. We are solving next example. So the procedures are first factor the denominator. Second, set up the equation. Third, multiply the equation by the LCD. Number 4, let x be convenient. Let's find convenience value. Number 5, So after finding the convenience value, we can solve maybe one or two of the A, B, C, or D's. But we may not finding all of them. That means we should do the last step is equate the equations to solve for the remaining constant. We'll talk about this one in the example. So first, let's factor the denominator. Yes, the denominator has been factored. I can set up my equation. So my equation on the top we say a divided by x. I think the line is too long. Let's make a short line. So a over x plus b over x squared plus c over x minus 2 plus d divided by x minus 2 squared. Now we need to find LCD. So the LCD is the factor of the bottom is x squared times x minus 2 squared. And then I should multiply both sides by the LCD. So multiply by LCD. On my left-hand side, I only have the top left. X plus 1 is equal to a times LCD. The leftover is a times x minus 2 squared plus b times x minus 2 squared plus c times x squared times x minus 2 plus d times x squared. So from this equation, we can let the, so first find the convenient, so the first one can find convenience values. So first I say, first the denominator. So from here, the first factor from the denominator, the x squared is equal to 0. That means x is equal to 0. Plug it into my equation. I'm having 1 is equal to, so which part are zeros? Here, here, and here. That means we only have the second part is equal to 1. B times negative 2 squared. And then 1 is equal to b times 4. And b is 1/4. So we can highlight this part. And the second, let's solve, find another coefficient, convenience value. Okay, finding that from here, x minus 2 is equal to 0, so x is equal to 2. The equation is 2 plus 1, which is 3, is equal to which parts are zeros? So here is 0, here is 0, here is 0. I can solve for the d. So we have d times 2 squared. We have 3 is equal to 4d. So d is equal to 3 over 4, 3/4. We can highlight this value. And then let's keep finding the a and c. But from the expression, we do not have other factors. So you see the factor here, the denominators. The factor x and x squared and x minus 2 squared. I don't have other convenience value. Now we will do the fifth step is equate the coefficient to solve the remaining constant. So how to equate? So come back to our equations here. So this is our equation. We need to expand our right-hand side. Okay, so let's expand. This is the step 5. X plus 1 is equal to a times x minus 2 squared is equal to x squared minus 4x plus 2, the plus 4 is equal to b plus b times x squared minus 4x plus 4 is equal to c, adding c times x cubed minus 2c times x squared plus dx squared. And then we should combine like terms. Sorry, I haven't finished combining the, clear the parentheses. So distribute the ax in the parentheses. We have ax cubed minus 4a times x squared plus 4ax plus bx squared minus 4bx plus 4b plus cx cubed minus 2cx squared plus dx squared. For the x cubed term, so here has x cubed, here has the x cubed. Let's combine them together. So we have a plus c x cubed. Then we should combine the squared, x squared, x squared, x squared, x squared. We have 4 terms x squared. They are, so we plus negative 4a plus b plus minus 2c plus d x squared. Then we combine the x terms, x. So that's all. So they are 4a minus 4b is times x. Last term is a constant term. We can use some other colors. So let's say pink. So let's use pink. 4b. Oh, 4b only? Yes, that's 4b. So let's plus 4b. Okay, let's see this. Do we have x cubed on our left-hand side? So here is the thing. So if I have another question, we have 4x is equal to ax. So if they all have the x part, that means 4 equals a. And if I have 3x cubed is equal to a times x cubed, that means a and 3, they are equivalent. So let's see on our left-hand side of the equation, do we have x cubed? No, we don't. That means a plus c is equal to 0 because there is no x cubed term. And then this equation, negative 4a plus b minus 2c plus d is equal to the coefficient of x squared. We don't have x squared on our left-hand side, so we can put 0 here. And then 4a minus 4b is equal to 1 because in front of the x we have 1. And lastly, we have 4b is equal to 1. So what are we looking for? We have the b, we have the d. We are looking for a and c. So which two equations has a and c? So here has a and c, and here has a. We can start from the third equation. So let's start from here. We can solve the easy terms first. Okay, we have b is equal to 1/4. 4 times a minus 4 times 1/4 is equal to 1. 4a is equal to 1 plus 1, 2. So a is equal to 1/2. Yes, we found the solution of the a. And how about last one, c? So we can bring the a's value in this equation, solve for the c. 1/2 plus c is equal to 0. So c is equal to negative 1/2. So we found all of the 4 constant. Then we can express our equation. So let's move our expressions here. So we're having a on the top. So that is 1/2. 1/2 over x plus b divided by x squared, 1/4 over x squared, plus c is negative 1/2, all divided by x minus 2, plus d 1/4, all divided by x minus 2 squared. Okay, let's simplify this. We have 1 over 2x plus 1 over 4x squared plus, minus 1 over 2 times x minus 2, then plus 3 divided by 4 times x minus 2 squared. So this is a solution. Let me box it. Let's see number 4. First step, let's set up the equation because the denominator has been factored. So this one is equal to a divided by x plus 2 plus b divided by x minus 1 plus c divided by x minus 1 squared. Yes, I meet my power 2. Okay, let's multiply by LCD. LCD is x plus 2 times x minus 1 squared. So multiply by LCD both sides. We're having our left-hand side is x squared plus x is equal to a times x minus 1 squared plus b times x plus 2 times x minus 1 plus c times x plus 2. And then we need to find the convenience values. First one, we can find the first one from our first factor of the denominator. Okay, we can say x plus 2 is equal to 0. Then I found that x is equal to negative 2. So plug it into the equation. We are having negative 2 squared on our left-hand side plus negative 2 is equal to a times, so which parts will make a 0? So let's see, this part and this part. So a times negative 2 minus 1 squared. So solve the a. We have 4 plus 4 minus 2, which is 2. So 2 is equal to a times 3 squared is 9. So a is equal to 2 over 9. We found our first constant number. So second, what should I do? I want to find another convenient value from here. X is equal to 1. X is equal to 1. Our left-hand side is 1 squared plus 1 is equal to, so which parts are our zeros? Here is 0, here is 0. That means we only have the c part, which is c times 1 plus 2. So we have 2 is equal to c times 3. C is equal to 2/3. So that's our second special value. And we don't have the convenience values. How should I do? Expand our right-hand side and list the equation. So the x squared plus x is equal to a times x squared minus 2x plus 1 plus b times, so FOIL it. So you should FOIL this one. So it's a little bit messy. We're going to have x squared, so minus x plus 2, x is plus x minus 2, then plus cx plus 2c. Continue to expand my right-hand side. We have ax squared minus 2ax plus a is plus bx squared plus b. Okay, yes, plus bx, then minus 2b, plus cx plus 2c. Let's combine like terms. Combine the x squared term together, and then combine the x terms together, and then the constant numbers. So the x squared plus x is equal to a plus b x squared. So plus negative 2a plus b plus c x plus a minus 2b plus 2c. We can list some equations. For example, a plus b is equal to 1. And then all of this is equal to 1 because in front of the x. And then rest of them, they are equal to 0 because I don't have the constant term on our left-hand side. So we are looking for the b. So I think only list the first equation is enough. So we can list that a plus b is equal to 1. A is given is 2 over 9. So 2 over 9 plus b is equal to 1. Both sides minus 2 over 9. B is equal to 7 over 9. So we put the ABC in the equation. We're having x squared plus x divided by x plus 2 times x minus 1 squared is equal to a over x plus 2. A is 2 over 9 divided by x plus 2 plus b. B is 7 over 9 over x plus 1 plus c. C is 2/3 x minus 1 squared. I have a mistake here. You see? Minus 1. All right, let's rewrite it. It is 2 over 9 times. Okay, 2 over 9 times x plus 2 plus 7 over 9 times x minus 1. And then plus 2 over 3 times x minus 1 squared. Let's see the type 3, non-repeated irreducible quadratic factors. So if our rational expression, the denominator, the bottom, is quadratic and non-factoring irreducible part. So for example, the denominator here is a quadratic. And the top must be linear. So the denominator cannot be factored. So the top cannot be a constant number, must has a linear form, which is ax plus b. So let's talk about this in the example. Let's see the example 5. So in the example 5, our old question says we should factor the denominator. So the denominator bottom has been factored. And then I can write this one into the a over x plus b over x squared, then plus, so we say c divided by the next factor. But look at the factor here in the parentheses. It's a quadratic. It is not a factorable quadratic expression. So that means on the top of this factor, x squared plus 2, x squared plus 2, we're having cx plus d. We're not having a constant number. We're going to have a linear form here on the top. So you can also say reduce one power from the denominator, the x squared. We have cx plus d. Okay, let's see. Next step is multiply both sides by the LCD. So LCD is x squared times x squared plus 2. Okay, multiply by LCD both sides, we have x cubed plus 5x squared plus 10 is equal to a times x squared plus 2 plus b times x squared plus 2 and plus cx plus d multiplied by x squared. What is the next step? Find the convenient values. So from here, I can tell x is equal to 0 is my convenience value. For x is equal to 0, my left-hand side is 10 is equal to, so here is 0, here is 0, so we have the b part. So the b part is b times 0 plus 2, or 0 squared plus 2 is 10 is equal to 2b. b is equal to 5. Okay, can I find another special value or the convenience value? No, because x squared plus 2 is not equal to 0. So if you say it's equal to 0, x squared plus 2 is equal to 0. The x is not a real number, minus 2 both sides. X squared is equal to negative 2. But it's impossible, so we are not solving this. What should I do? I need to expand my equations. So expanding my right-hand side, we have x cubed plus 5x squared plus 10 is equal to a times x cubed plus 2ax plus bx squared plus 2b plus cx cubed plus dx squared. Let's combine like terms. X cubed term, x squared, and x and constant. So let's rewrite it. So 3x cubed plus 5x squared plus 10 is equal to ax cubed plus 2a. I forgot to combine like terms. So a plus c x cubed plus the squared term is b plus d x squared plus 2ax plus 2b. Okay, b has been solved because I have seen that b is equal to 5. I'm looking for c, a, c, and d. So we can highlight our 5. So from which part I can find my A, C, and D. So here, so use different color. A plus C is equal to 1 because in front of the x cubed is 1. B plus D is equal to 5, and then we don't have the x term on our left hand side. That means 2a is 0 and 2b is equal to 10. Okay, so we can starting from a plus c. So a plus c is equal to 1. And then b plus d is equal to 5. And then 2a is equal to 0. 2b is equal to 10. We don't have to solve this because we got the b's value, which is 5. So from the last one, a is equal to 0 divided by 2 both sides. And then we say b is equal to 5 plus d is equal to 5. So d is equal to 5. D is equal to 0. And the first one, a plus c is 1, a is 0. 0 plus c is 1, c is 1. So we have the a, b, c, and d's value. So they are c is 1, d is 0, a is 0. Okay, we have some easy numbers. Okay, plug it into the equation we're having. So I will not copy the question. A over x, A is 0, 0 over x plus b, 5 divided by x squared, plus cx plus d. C is 1, so 1 plus 0. So it is 1 divided by x squared plus 2. We can eliminate the first term. So it is 5 over x squared plus 1 divided by x squared plus 2. Before we start example 6, let's review sum or difference of cubes. If I have a cubed plus b cubed, I can factor it. It will be a plus b times a squared minus ab plus b squared. If I have a cubed minus b cubed, it is a minus b times a squared plus ab plus b squared. All right, pause the video and copy down the formula. Let's see example 6. Example 6, we have a rational expression. We want to decompose it. So first step is factoring the denominator. So the denominator bottom, it is a difference of cubes. So we say the bottom is x minus 1, this is a minus b, times a squared, which is x squared, then plus ab, x times 1. It is x, and last term is plus 1 squared. It is 1. So maybe some of you say, I didn't see my a squared and b squared. So a squared is x cubed, b squared is 1 cubed, which is 1. On the top, so it's 2x plus 4. We should decompose it. So denominator bottom, we have 2 factors. So the first factor is linear. So this one is linear. Second one, can you factor out the second factor? X squared plus x plus 1? No, it's non-factoring and trinomials, or non-factoring quadratic form. That means the second factor, the top should be a linear. So the first factor, so this one, let's separate the 2 factors. X minus 1. Since this one, bottom is linear, the top is a constant number, plus the second factor, x squared plus x plus 1. So this part is non-factoring, and also this is quadratic form, or the trinomial. So the top must be bx plus c. It's a linear form. The linear form is, let's say ax plus b is a linear form. Okay, we set up the equation. We can move this equation down, which is 2x plus 4 divided by x minus 1 times x squared plus x plus 1 is equal to a over x minus 1 plus bx plus c over x squared plus x plus 1. And next step, we need to multiply both sides by LCD. LCD is, x minus 1 times x squared plus x plus 1. So multiply both sides, we're having 2x plus 4 is equal to a times x squared plus x plus 1. And then second part to the top, b, let's wait for saving, bx plus c multiplied by x minus 1. Okay, next step, let's find the convenient value. So the first convenient value is coming from Okay, you can also say it's from my LCD first factor, x minus 1 is equal to 0. So we say x minus 1 is equal to 0, x is equal to 1. So plug this one into my equation. I will make this part 0. So we have 2 times 1 plus 4 is equal to a times 1 squared plus 1 plus 1 plus 0. So let's solve for the a. We have 6 is equal to a times what? A times 3. A is equal to 2. Okay, let's solve the other two variables. Another two constant number, b and c. All right, can I choose another convenient value? No, because this part I cannot solve for the x. So next part, we should expand both sides. I need to expand my right-hand side of this equation. We have 2x plus 4 is equal to, distribute the a, we have ax squared plus ax plus a. And then the multiplication between two binomials, we can FOIL it. We're going to have bx squared minus bx plus cx plus, minus c. Let's combine like terms on our right-hand side. 2x plus 4 is equal to, let's combine the x squared, and then combine the x terms, and then constant numbers. So we have a plus b x squared plus a minus b plus c x plus a minus c. All right, so look at our left-hand side. So do we have x squared term? No, that means a plus b is 0. Do we have x? Yes, we have x. So x is here. That means a minus b plus c is equal to 2. And the 4 is equal to a minus c. Let's list the equation. So the equation is a plus b is 0. Because we don't have x squared on our left-hand side. And then 2 is equal to a minus b plus c. Last one is a minus c, or we say 4 is equal to a minus c. We already found one solution, which is a is equal to 2. We need to find b and c. From the first equation, I have 2 plus b is equal to 0. b is equal to negative 2. And then I'm looking for the c from the last equation. So we have 4 is equal to 2 minus c. So c is equal to negative 2. Okay, we got our a, b, c's value, b and c. We can list the equation. So let's move up a little bit. So replace the a. So the a and the bx plus c with the a, b, c's value. Okay, so the expression, the decomposed expression is, I can write it here. On the top is 2. 2 over x plus 1. Minus 1. Plus b is negative 2. X plus negative 2 plus c. So divided by x squared plus x plus 1. Okay, so this is a solution. All right, let's move on to see type 4. In type 4, repeated irreducible quadratic factors. Okay, if my factor, for example, I don't worry about my top, but the bottom is ax squared plus bx plus c, and this one raise it to the cubed. On the top is p of x is a top polynomial. a function. So look at the bottom. We have ax squared plus bx plus c. In the parentheses part is non-factoring quadratic terms, quadratic forms. That means we can rewrite it, decompose it like the following expression. The ax squared plus bx plus c. On the top is a linear form, is ax plus b, because the bottom is non-factoring quadratic factor. And then we raise this factor to the second power. The top is also linear form, cx plus d. And the last one is raise it to the third power until I missed the power 3. So this is a third rational expression, rational part. So the top is also linear expression, which is ex plus f. Okay, let's see. Example 7. The bottom. Can you keep factoring the bottom? No, because in the parentheses we have x squared plus 4. I cannot factor it. This is a non-factoring quadratic bottom, or quadratic form. Okay, so what should I do next? Rewrite it or decompose it. So the denominator is x squared plus 4. This is the base of our 2. On the top, so the bottom is a quadratic form. On the top is a linear form, is ax plus b. Then plus, raise it to the second power until I meet the power 2. So the top is also a linear form with a cx plus d. Now we know that LCD is x squared plus 4 squared. Let's multiply the LCD, both sides of the equation. I don't want to copy it. So we're having x cubed plus x squared is equal to ax plus b multiplied by x squared plus 4 plus cx plus d. All right. Let's find any convenience value. Do we have any convenience value? No. So from the LCD, we say x squared plus 4 is equal to 0. If I solve for the x minus 4 both sides, we have x squared is equal to negative 4. This is not a real number. So later, I can solve for the x like the complex number. We have the imaginary I part. So we're not solving it. We're solving it in the real number system. So there's no, I erase the LCD. There's no convenience value. So we should expand our right-hand side. We have x cubed plus x squared, and we FOIL the right-hand side, the two parentheses. We are going to have ax cubed plus 4ax plus bx squared plus 4b plus cx plus d. Let's combine like terms on our right-hand side. Don't combine our left and right together, only combine the right-hand side. Let's highlight the like terms. Cubed, no other cubed. So I don't have to highlight cubed. I can highlight the square. Nothing can be combined. And let's highlight the x part. At least the x can be combined. So let's reorder it. Ax cubed plus bx squared plus 4a plus cx, then plus 4b plus d. Let's list the equations. So in front of our x cubed, we have the coefficient 1. That means a is equal to 1. And how about the squared? So in front of the x squared is b. is 1. So b is equal to 1. So b is equal to 1. And the next equation is 4a plus cx. We don't have the x term on our left-hand side. That means 4a plus c is equal to 0. And we don't have a constant term on our left-hand side. So 4b plus d is equal to 0. First two terms solved the a and b. So let's see the last two equations. We have 4 times 1 plus c is equal to 0. C is equal to -4. And here, 4 times 1 plus d is equal to 0. D is also equal to -4. We solved our a, b, and c, and d. So plug them into the decomposed expression. So we are going to have our decomposed expression like this. So on the top, we have ax plus b is x plus 1 divided by x squared plus 4. Then plus cx plus d is -4x minus 4, all divided by x squared plus 4 squared. So this is the solution.